This is the Coosa Middle School Weather Channel.
No, it's weathering, not weather. You're a science teacher, not a news reporter.
Oh, well, in that case, let's talk about weathering. We have several different kinds of weathering. In fact, there are two primary kinds of weathering, mechanical weathering and chemical weathering. But let's talk about what weathering itself is. Weathering is when nature breaks down rocks. When nature breaks down rocks. We've been talking a lot about rocks, and the two kinds of weathering we're going to talk about are going to be mechanical weathering and chemical weathering. Mechanical weathering is wearing down of rocks that does not change the rock's composition. It's like cracking a pecan. The pieces of the pecan are still pecan, it's just broken. You can see on the screen we have some common forms of mechanical weathering, and we'll go over each one of these: freezing water, rock layer shedding, plant growth, and water friction. Let's go with some pictures. The first one up in the very top is whenever you have the effects of frozen water. Now, this is called ice wedging. This is called ice wedging. You can see the rock here had water that crept into it, and then once it got cold enough to freeze, it froze. Now you probably know what happens whenever water freezes. It expands. So that's how the expansion breaks up this rock here. And that's a very powerful form of weathering, breaks rocks up. A second form is something called exfoliation. Exfoliation simply is when layers shed like an onion peel. And if you can see this rock right here, it just seems like it's shedding an outer layer. Now here's what scientists think happened here. They think this rock was once under the surface, probably was an intrusive rock. And the pressure on it was very strong, but whenever it broke through the surface, when other things eroded around it, then that pressure was no longer there. So that makes the top layer a little bit weaker. That's what scientists think on that one. A third part of mechanical weathering is shown right here, where you have plant growth. Now the growth of trees and the growth of plants is very strong, and it can actually break through rocks. And you can see here how this tree has just it was rooted, and it grew up through this rock, and this rock is broken as a result of that. And a fourth form of mechanical weathering is water friction. Water friction, or something called abrasion. I must have forgotten to type this out, but it's called abrasion. Now if you notice, all of these rocks in this stream here, these pebbles in the stream, are rounded. Now the reason why you find rounded pebbles in a stream is because you constantly have water flowing over it, and it creates friction and it rounds the stones. Ocean waves have kind of the same effect. They create friction, and they kind of polish whatever happens to be there, and it chips away the outer edges and just leaves the inner circular stones. Now let's go back to the original page. You can see we've talked about the four aspects of mechanical weathering. Freezing water was ice wedging, rock layer shedding was exfoliation, plant growth, and then you had abrasion with water friction, not fiction. Water friction was abrasion. Here you have chemical weathering. Now we said mechanical weathering was where the rocks do not change the composition. The wear down does not change the composition. You can imagine what chemical is. Chemical weathering is when you have wear down of rocks where the rock's chemical makeup is changed. Chemical makeup changed. And that's not the case with mechanical weathering. It is not changed with mechanical weathering. You can see a couple of examples we have here: minerals and water and acid rain. Let's go to the pictures. At the top you can see an example of acid rain. Well, I suppose I should go back to this original picture and try to explain a little bit more before I get there. An example of chemical weathering would be like a rusty nail. You have oxygen and water that react with iron to form rust. It's actually changing its chemical composition. And that happens in nature too. Most chemical weathering has to do with the way minerals react with water. That's what most chemical weathering has to do with. Some minerals like halite, table salt, do dissolve in water, and others dissolve in water that's more acidic. That's where the dangers of acid rain comes in. So now we can go to the pictures. That's where I have something that has to do with acid rain. Here we see this photograph of a statue that was made in the early 1900s. And here's the photograph of the same statue made years and years later. I forget exactly how long, but it was something like 60 to 80 years later. And you can see the dramatic difference. Here, this statue has a face and has visible features you can see, but here it's just worn down. Now here's the process that happens. When you have polluted air makes rainwater more acidic. Now, how do we get polluted air? Things like power plants and automobiles. They produce gases that increase the amount of acid in the rain. Now, you see this picture. This didn't happen overnight. I mean, you're not going to walk out and have acid rain fall on you, you die on the spot. This is something that happens over a long period of time, and it just wears things down like statues a little bit more. And there's some other effects of acid rain we'll continue to talk about in this class. But generally, rocks dissolve a bit more quickly with the presence of acid rain. Now, down here at the bottom, we have a picture of a canyon. This canyon has iron oxide in it. Now what's happening whenever you have rain and the oxygen in the air, it reacts with the iron that's in this oxide and actually forms rust naturally. You can see all this red area here. That is naturally formed rust. And that's another form of chemical weathering. It actually changes the composition of what you have, the rock that is wearing out. So, in review, we have two different forms of weathering: mechanical weathering and chemical weathering.